Hello and welcome. This is a lesson on chemical equations. Get ready to learn. We have a representative of a molecule here, a representation of a molecule. We're going to learn about it because predicting what will happen when two or more chemicals are combined would be a good thing to know. You can tell how much of each chemical is needed to produce a certain amount of the new chemical compound. Suppose this is a vitamin or a flu shot. Be good to know how many of these white ones you need and how many of the red and how many of the gray. Did you know chemical reactions happens when atoms break free of chemical bonds and form new substances with new chemical bonds? We have oxygen here. They like to hang out together. We have methane here, carbon, hydrogen, 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 hydrogen. And again, more oxygen here, O2. And again, these are two atoms of oxygen that hang around together. When you combine these in the right way and have a chemical reaction, these break up their molecules, or they're hanging out with their buddies, and they form something new. The chemicals are named by a common name or a shorthand symbol. C for carbon, H for hydrogen, O for oxygen. Then they have some others that are made from their Latin names or their Greek names. Long time ago. Using mathematics, we can predict what will happen in a chemical reaction by counting the atoms and balancing chemical equations. And elements are chemicals that cannot be divided into smaller parts. These are the individual elements. Describing a chemical reaction. We can write it out using words. Dihydrogen monoxide. Two molecules of hydrogen gas react with one molecule of oxygen gas to produce two molecules of water. Dihydrogen monoxide, another name for H2O. We can use a shorthand. It shows the mathematical relationships. Two molecules of hydrogen, two H2s, react with one molecule of oxygen, O2, produce, here's your reaction, two molecules of H2O. Or we could draw a picture or a model. Here's that same thing in a model. Two hydrogen, one oxygen, one oxygen. This is over here, right? We have two, H2O, H1, H2, O, one molecule. So we have two of these. So here's one, and here's the other. So we can describe a chemical reaction using words, using mathematical relationships or shorthand, or draw a picture of it. Naming the elements. H, hydrogen, was Greek for hydro, and gen, water forming. Now, that came out of water. Here's some other ones. C for carbon, O for oxygen. Then we get into some, he's like, how does sodium, Na? Well, the Latin name for sodium is natrium, Na. Iron, ferrum, Fe. Silver and gold, again Latin, Ag, Au. Mercury, Hg, meaning water silver. That's the metal that's liquid at room temperature, Hg. And then we get some of the newer ones, Einsteintinium, Es, for Einstein. I named it after him. Okay, here's how we write chemical equations. There are two numbers to watch, the coefficients and the subscripts. Coefficients come before. Subscripts are the smaller ones that are under. Sub meaning below, like submarine, underwater, undermarine. So we have the coefficient and the subscript. Two water molecules have 6 total atoms. How do you get 6 out of this? Let's see. 2 hydrogen, 1 oxygen makes 3 atoms in a molecule of water. We know that. 2 molecules have double the amount. The large number in the front is the number of molecules. It's called the coefficient. So we have our friend H2O, and we have 2 of them. Now the smaller number under the letters is the number of atoms in each molecule. So in each molecule of H2O, there are 2 H's, hydrogens. So let's do the math. Start here. You have 2 hydrogen. There's no subscript there. Well, there are always numbers. If there are no coefficient here, this one has 2. If there's none there, the coefficient is 1, because 1 times anything is that. If there are no subscripts, the subscript is 1. So let's add it up again. 2 H's is 2. 1 O is 3. We have 3 atoms in each molecule, but we have 2 molecules. 2 times 3, 6. So 2 water molecules have 6 total atoms. Not hard. Balancing chemical equations. There are 2 numbers to watch, the coefficients and the subscripts. What you start with is got to be what you end with after this reaction here. The equation must balance in the reaction. So let's look at what we have here. Remember, hydrogen, here we are with the H, hangs out with a buddy. So they form a molecule H2. Oxygen does the same thing, O2. So, to balance this all out, my goodness, we start with 2 oxygen, we got to end with 2 oxygen. In order to make this balance, each one of these oxygens needs 2 hydrogen. So let's look at the numbers. 2 oxygen, 2 oxygen. 2 molecules, each one containing, remember, if there's no subscript, the subscript is 1. So Let's do the math. There's no coefficient here. The coefficient is 1. So here we go. 1 times 2 is 2 oxygen. 2 times 1 is 2 oxygen. From a picture, 1, 2, 1, 2. We're good. Let's do the hydrogen. 2 hydrogen in each molecules, and we have 2 molecules of hydrogen. So we're going to have double the number that there is in oxygen. 1, 2, 3, 4. As in 1, 2, 3, 4. Let's get the math again. 2 times 2 is 4. 1, 2, 3, 4. So we have 2 hydrogen in each molecule of hydrogen and 2 molecules of hydrogen. So 2 times 2 is 4. After the reaction, we have 2 hydrogen in each molecule of water and 2 molecules of water. So 2 times 2 is 4. Have 4 on the left, 4 on the right. 1, 2, 3, 4. There you go. It's a little tricky, I understand, but it gets easier once you start figuring the math. What you start with, what you finish with. These are the hydrogens. What you start with, what you finish with. These are the oxygens. What you start with is what you finish with. Now we got a couple of different kinds of chemical reactions. We got a simple combination where atoms are combined chemically. The reactants, that's what you start with. It's on the left side of the arrow. When you have a reaction, that is the arrow itself, and it yields the products. So when A reacts with B in a chemical reaction, you get the molecule AB. This is an element, this is an element that gives you a molecule. There are different types of reactions, though. You can have AB reacting and then separating into A plus B. You can have A and B together reacting with C and get A and C together giving you B. Then you can have a double replacement where C replaced B. You can have A and B and C and D, which after your reaction gives you A and C and B and D. But the law of conservation of mass says whatever you start with is what you finish with. No material is destroyed in the reaction. No new material is created in that reaction. Here's the law of conservation of mass again. We got methane reacting with oxygen. Gives you CO2, carbon dioxide, and water. It also releases energy. This is burning gas. In a reaction, no new atoms are made or destroyed. Let's count the number of C's we have. We have, remember, 1 here, there it is. 1 here, there it is. So the black ones, the carbon, balance out. Let's do the hydrogen. Remember, if there's no coefficient, it's 1. So 1 times 4 is 4. 1, 2, 3, 4. There they are. What do we have after? We have 2 water molecules. Each water molecule has 1, 2 hydrogen. There they are. And we have 2 molecules. 1, 2. That's where the coefficient comes from. 2 times 2 is 4. 1, 2, 3, 4. 1, 2, 3, 4. We're good. The only thing left is the oxygen. Let's hope that adds up correctly. We have 2 molecules. That's the coefficient. Each molecule contains 2 atoms. There's the 2 atoms per molecule. 2 molecules. 1, 2, 3, 4. 2 times 2 is 4. When the reaction happens, we get CO2, 1, 2 oxygen, and 2 water molecules, 1, 1, 2 oxygen, right? Remember, no coefficient, it's 1. So 1 times 2 is 2. No subscript. If there's no subscript, the subscript is 1. 2 times 1 is 2. 1, 2. So we have 1, 2, 3, 4. 1, 2, 3, 4. We have balanced it. These atoms over here recombine in a reaction in a new way. New bonds are made, something new is created out of the rearrangement of the atoms. Here's a periodic table. It contains important information about each of the elements. It gives you the element name, the element symbol, the atomic number, and the atomic mass. Here's oxygen. It's the element symbol, the element name, the atomic number, and the atomic mass. Atomic number is, let's go back. The atomic number is the number of protons in the nucleus. The atomic mass is the mass, the amount of stuff in the nucleus, which is the protons and neutrons. It gives you a lot of information. So why is this important? Predicting what will happen when 2 or more chemicals are combined would be a good thing to know. You can tell how much of each chemical is needed to produce a certain amount of the new chemical compound. Here's your lesson on chemical equations.